So we analyze now the sequence of laws that emerged from chemical studies. And as I mentioned before, these laws define the benchmarks against which both experiments could test those laws and also how they could transform the way science and scientific opinion transformed through the clarification of those laws. And so 1799, another French chemist, Joseph Proust, convinced many scientific skeptics that the elements that make up a given compound are always present in fixed proportions. And again, this seems obvious to us now, but the idea that this proposed continuum of matter was actually broken down into individual elements that appeared in fixed proportions was extremely interesting and extremely important for an understanding of atomic theory and atomic structure. So Proust formulated the law of definite proportions. That law states that independent of its source, a compound is composed of the same elements with the same fractional contribution. So let's take an example. Let's take 20 grams of calcium carbonate or sandstone. When this is analyzed by mass, it turns out that 8.0 grams come from calcium, and so we can calculate the ratio of calcium to the overall structure of calcium carbonate. That turns out to be 40%. We can analyze carbon, 2.4 grams of carbon in this sample. So we have 2.4 divided by 20. That gives us 12% of calcium carbonate composed of carbon by weight. And then 9.6 grams of oxygen gives us an additional 48%. And so Joseph Proust analyzed compound after compound and came to the remarkable conclusion that every time he analyzed one of these substances, it had exactly the same proportion of elements contained within it. Next came the law of multiple proportions. It was 5 years later, in 1804, John Dalton, and he was an English physicist and chemist, and he proposed the law of multiple proportions. It says that when two elements, A and B, react to form two different compounds, the masses of B that combined with a fixed mass of A can be expressed as a ratio of whole numbers. That is, let's take the fixed mass to be carbon and the other to be oxygen, and he realized that that could be combined to form CO, or carbon monoxide, but it could also be combined to form CO2, or carbon dioxide. So this was a very important piece of insight into how these entities which formed those compounds actually combined with one another, and that it wasn't simply always the same proportion. It depended on what that compound was, but there was always a simple numerical relationship between the number of entities that formed that compound in one example versus another.